What is up, Algebra 1? It is your host with the most. Bring the toast out of the oven. Ha, 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 ha. It's hot. Put it back in the oven. Wait a little bit. Alright, it's cool now. Now I eat it. Hey, it's Mr. Knight. How's it going? We're back with another Algebra 1 lesson, y'all. Okay? We have a new and final method of actually solving systems of equations, and this is called the elimination method. Ooh. It's actually pretty cool. Basically, elimination is it's a way to solve system of equations by eliminating a variable. When we are working with systems of equations, we're usually just working with x or y, so it just boils down to getting rid of your x or your y. So how do we do that? Well, there's a couple things we need to go over. Okay. First of all, when we have linear equations, so let's just say right now I have 2x plus 3y equals 5 and 5x minus y equals 15. What I can do is I can actually add my equations. Yeah, what I can do is I can add these guys up, and I'm going to combine my like terms, right? So I'm going to add my x's. 2x plus 5x gives me 7x. 3y minus y, that gives me plus 2y. And then 5 plus 15, that gives me 20. And look, I have like this new equation that I can come up with, right? It's in reference to both of these equations, kind of like sandwiched, merged together, right? We're allowed to do that. The problem is, well, now we have one equation, and we still have two variables, so that kind of stinks, okay? But let's continue on with that idea a little bit later. Let's also look at this. We can also multiply our equations by numbers to get equivalent equations, right? So what I can do is I could take both those equations, right? And now let's say I multiply the top one by 2. Well, I'm multiplying the entire equation by 2, so it's almost like I'm distributing this 2 to each of those parts in my equation. So 2 times 2 gives me 4x, 2 times 3y gives me 6y, 2 times 5 gives me 10. And likewise, if we look at this one down here, 4 times 5x gives me 20x, and you get the point, right? We're just multiplying each of those things, and now we have two equations. They have just been multiplied. This one's multiplied by 2, this one's multiplied by 4. But equivalently, I don't think that's a word, but equivalently, they are the same thing. They're just multiplied by a factor of something, okay? So if we can add and subtract our linear equations, and we can also multiply our equations by something, using those two ideas, we can actually do the elimination method. So with the elimination, we want to multiply our equations, like we did here, by something so when we add and subtract them, x or y gets eliminated. Just one of them, right? So for example, if I take my 2x plus 3y equals 5 and my 5x minus y equals 15, I can think, what can I multiply by for one or both of my equations so that one of my variables will get canceled out? Well, it turns out, in this example, and this is just one example you could use, I notice if I multiply each of these by 3, well, now I'm going to end up with 2x plus 3y equals 5 on top, same thing. But on the bottom, I get 15x minus 3y equals 45. And what happens to my y's? They cancel when I add them together, right? I can now add them together, so I get 17x equals 50 after I add the 5 and 45. And now I can solve for x. I can divide both sides by 17 and get x solved for. So this elimination process is really nice, and it's actually, in a lot of ways, better than substitution, okay? Not always, and sometimes we do have to rely on substitution, even with elimination. Let's see some examples. Let's get these under our belt and see what we can do. So this first example, we're going to solve this system for x and y. 3x plus y equals 9, 5x plus 4y equals 22. Okay, I got to think, what can I multiply by? Because that's what I need to find. I need to find out what I can multiply each equation by to get one variable to cancel. Well, if I multiply the top by negative 4, I'm going to make this a negative 4y, and then if I leave the bottom the same, negative 4y plus 4y, those would cancel, and that would work out. So that's actually what I'm going to multiply my top equation by, is negative 4. So let's see that. I go ahead, I multiply the top equation by negative 4, and so I get negative 12x, right? I got to keep my signs in mind, so a negative times a positive is still a negative. So I get negative 12x minus 4y equals negative 36. One of the biggest mistakes kids make is that they don't multiply this number to every part of their equation. Maybe they'll only do the left-hand side. No, do it to everything, okay? So we get this new equation up top. I'm going to move this guy underneath it, and I'm going to add my like terms together, right? So again, the 4y and the negative 4y, they cancel out. So I'm left with, on the left-hand side of my equation, negative 12 plus 5 is negative 7x, and that's equal to negative 14. And so to solve for x, I need to divide both sides by negative 7. And so after the negative 7's cancel here, I get x is equal to positive 2. Well, now what I can do is I can substitute or plug in that 2 into either of these equations. So I'm still using substitution. Okay, we still need to use substitution, but kind of in that traditional sense of checking for your answer, right? So if I plug 2 into the top equation, I get 6 plus y equals 9, y equals 3. I got an x and a y, and that is how you write your answer still, right? Just like we did with substitution. So my answer is 2, 3. Okay? Let's see another example of this, all right? Now I can look at this and I could say, okay, this is a little different than example 1. Example 1, we just had like y just chilling on an island. Here, everything has a number by it, okay? Well, if I look at this, do I actually need to multiply anything to start this problem? Or can something cancel out right away? Turns out, yes. The two x's will just cancel out right away when I add them. Okay? So I don't actually need to multiply by anything. That's really nice of this problem. Thanks for looking out for a guy. I can now just add and subtract my equations. So I go ahead and do that. So I take my equations, two x's cancel out. I'm left with 8y equals 16. And so I divide both sides by 8, and I get y equals 2. Once again, I have y equals 2. I can plug that 2 into y into either of these equations. I ended up just going with the top one, and I solve for x. So I plug it in for y, so I get 6 plus 2x equals 6. Subtract 6 from both sides, to start with SADMAP. Do subtraction addition first. Okay, now I'm multiplying by 2, so to undo the times 2, I got to divide both sides by 2. Or, in this problem, you can just realize, hey, if I plug in 0 into this guy, I'm going to get the right answer. X is equal to 0. Therefore, my answer is 0, 2, x, y. Okay? Let's see our final third example. We're going to solve this system. And we're not going to solve it any differently than we did the other ones, right? We have these two equations. I got to think, do I need to multiply any of those equations by something in order to get either the x's or the y's to cancel? Okay? Well, let's say I want to get the x's to cancel. Okay? To get the x's to cancel, I got to multiply the equation, this bottom one, by negative 2. Because if I do that, I'll get negative 2x down here, and when I add them, they'll cancel. It's great. So let's go ahead and do that. Well, when I do this, I get, on the bottom, after I multiply this negative 2, I get negative 2x minus 8y equals negative 8. Okay? Let's go ahead and add those. Well, when that happens, the x's cancel out, the y's cancel out, and so I get 0 on the left-hand side. They cancel out to 0, right? So, 3 minus 3, or, negative 3 plus 3, 8 minus 8, they all equal 0. And that equals negative 16. That is not true. And if you remember from substitution, if that's not true, when we get a contradiction where we're like, no, that's no solution right there. We don't have a solution. We don't have anything for x and y that's equal to those things. So we can just write no solution, or do the 0 with a dash through it if you want to be cool. All right. So that brings us to 3 types of answers. And once again, they're the same types of answers that we've been seeing this whole time. Okay. You either get one solution, so x, y. That's what we got in example 1 and 2. You may get no solution, where you get a contradiction. 8 equals 16. No, it doesn't. So there's no solution. But you can also get infinite solutions out of this, okay? Where if you get 8 equals 8, obviously that's true. we have infinite solutions. Okay? So definitely still watch out for those things as you go through these elimination problems. Okay? This is Mr. Knight signing off. We'll get some practice on this Monday and Tuesday, depending on when you're watching it.